My name is Jason Amaturi, and I'm going to be your host for the next hour during this session. So you might ask yourself, what is 3MT? And for those who don't know, 3MT stands for 3-minute thesis. And what does that mean? Well, participants in this session will have to present their research topic in no more than 3 minutes and using only one slide, okay? Now, for many of my students, they're probably thinking, well, they have to do a 3-minute presentation, they do one slide, how easy is that, right? But actually, it's actually quite the contrary, right? Being able to present your whole research within 3 minutes using one slide is no easy feat. You have to talk about your background, your rationale, your aims, what you did and why you did it and what it means, all in 3 minutes. But the key is using language that anyone can understand. So you should be able to present this talk to your grandmother at home and she should get what you are talking about. So that's the kind of level that we're at here. Okay, so definitely I'll tell you 15 minutes is probably a bit easier. 45 minutes is even easier than that. So we'll see how they go. So congratulations to all the participants that have made it into this session. The abstracts were very competitive, so we did have to decline many of them. So well done to getting here so far. I'll just tell you a bit about the awards. So the first award is for the best 3MT presentation. Now this one's formally judged by MSA faculty volunteers who have set criteria that they'll score each participant on. Now the second award is the People's Choice Award. And that's you guys, the audience, are going to be the judges and determine which one of these talks is the best presentation. So what I advise you to do as you're listening to these talks, note down who you thought was really good and keep that person in mind, and if someone else comes and beats them in your mind, replace them with it, because there are going to be 12 speakers, so it's going to be a lot to handle, so please make sure to keep note of it, and stay until the end so I can show you how you can do this judging. It's going to be very quick and easy, so please make sure not to leave. Now to tell you a bit more history about 3MT, it's actually an Australian-born invention, so first introduced in 2008 in Australia, and this should be of no surprise to you because we know that all great things come out of Australia, don't we? Right? I'm not biased whatsoever here. So given the Australian flavour to this session, I thought I'd enlighten you a little bit on some Aussie slang. And Aussie in itself is short for Australian, so it's a bit of slang for you. So when you go to Australia, you're going to be fitting right in with the crowd, okay? So the first one, which is used every day, is mate, okay? So mate's just another way of saying friend or a term of endearment, or it could be to a stranger, like, hi mate, how you doing? G'day mate, we'll talk about g'day soon later. How are you doing mate? That's like saying ya zalami or ya habibi or ya sahibi in Arabic, right? So it's the same kind of thing, you say it to anybody. So I've already said this one, but g'day. So g'day is short for good day. So another abbreviation of hi, if you like. So yes, g'day mate. G'day, we're always very popular in Australia. Arvo is short for afternoon. Now you're probably going to get the idea that Australians are a bit lazy and they like to abbreviate, okay? You're partially true, because we also swallow our R's too. We don't think R means anything, so we kind of eat it right up. There's no R in our words. This one's probably not as obvious. Tucker. Anyone want to hazard a guess as to what tucker means? No? No? Means food. Okay, so this is some good tucker. Let's go back to my place for some tucker, so food. Now the last one is even less obvious. Fair dinkum. Any ideas for this Ideas 2023 meeting? What does fair dinkum mean? No takers? Well, it means true or genuine. So you could say like, fair dinkum, this is the best faculty in the universe, right? Or you could use it as a questioning. Fair dinkum, mate. Like, are you serious, mate? Okay, so there you go. Remember these, it'll take you a long way when you go to Australia, okay? All right, let's get back to the topic at hand. So these are our 3MT presenters. There's 12 of them. They come from different departments within the faculty. There's a whole variety of talks there. So I think you're going to be in for quite a spectacle. Now, our first speaker is going to be Nasreen Bakri, who's going to talk to us about ultra-flexible devices for stimulating the brain by lights. So thank you, Nasreen.
Thank you, Dr. Jason. Hello, everybody. I'm sure that everybody of you knows someone suffering for Alzheimer's, Parkinson's, or epilepsy. Personally, my grandfather struggles with Alzheimer's. When I go to him, I have to reintroduce myself every 10 minutes and see him suffering with something as simple as remembering his loved ones. So Alzheimer's, along with epilepsy and Parkinson, are devastating diseases affecting millions of people. And one of the solution is electrocorticographies placed on the surface of the brain and can record and modulate brain activity to decrease the symptoms of these diseases. So it should be flexible and it should be non-invasive. However, currently ECOGs are invasive, needs many sometimes surgeries to be implanted and removed back, and their flexibility is limited, causing discomfort for the brain tissue and affecting the functioning of the ECOG. So I'm presenting today a device which is ultra flexible, developed by inkjet printing, and which is a technology utilized to deposit ink, conductive inks to form sensing electrodes and stimulating electrodes. The device is fully biodegradable. It can be left safely in the brain without the need of surgery to get it back. And currently, to stimulate the brain, we are using electrical impulses. What puts our device apart is that he can stimulate the brain by light. Actually, we can control some cells in the brain that are genetically modified and are now sensitive to light. This is called optogenetics. For example, for Alzheimer, we can control or stimulate parts of the brain that are responsible of memory. And for epilepsy, we can calm down some the neuroactivity of some neurons to reduce the seizures. In the end, our device is 40 electrodes and 2 by 2 millimeters.
We have to stop you. So I didn't mention it's actually a strict 3 minutes, not a Lebanese 3 minutes. Not offense to you. That's my yes. That's where my phone is. Okay, thank you, Nasreen. Okay, so yes, there will be an alarm. Thank you very much. Okay, so our next speaker is going to be Aya Youssef, When Water Builds Spaces. So Aya.
Right, one sec. Okay. Hi, everyone. 6,500 BC. That's when concrete was first used as a building material. Until the 1900s, it regained its public acceptance. But it's 2023, and we're still using concrete. We're still quarrying our lands and exploiting material in order to build. But these buildings actually contribute to 40% of global CO2 emission. Did you know that? This is leading to climate change, global warming, and increase of rising sea levels. And this is a global concern that's even touching our Mediterranean seas. And this is touching also Lebanon as one of the countries sooner or later. But until when? It's time to rethink our construction methodologies. So here comes my thesis question. How can architecture actually resign from this process and from accelerating rising sea levels? Well, that's my focus of my thesis, where it requires and recognizes the need of working with water rather than against it. It recognizes the need of working with the sea as a new medium to explore and experiment with BioZ technology, rather than the traditional building techniques. So BioZ is a new method in which it uses low voltage electric currents that will solidify minerals that will look like rocks around the steel structures that we actually use underwater. These structures can be in any form and in any geographic location, but this is based on ecological aspects in which it will decrease the risk of coastal erosions, it will increase the marine biodiversity, and will protect our coastal cities from rising sea levels in the future. This is a design tool in which I can use it to design a growth process and let the nature be part of this designing process as well. It's also a new building construction method in which we replace the concrete cement or the concrete cement making process or the CMU blocks with biorock blocks in which we can create any space we want. And we would involve the community to build their spaces anywhere. Imagine a future, a sustainable future, where we have buildings with zero carbon footprint on the land or on the sea, above or below water. Imagine this future where nature itself can actually regenerate and self-heal the spaces in case of any damage. Well, let's give this technology a chance in architecture in order to rebuild a better future from the land to the sea. Thank you so much.
Okay, thank you, Aya. So our next presenter, is Bara Hatem Al-Haj Hadi. Can microbes on the Lebanese shoreline clean up tar pollution?
Sorry. Picture on top shows a green turtle. Can I repeat? Okay. The picture on top shows a green turtle, an endangered species that seeks a home in the Tier Nature Reserve every year. But in 2021, it was found dead on the beach, enveloped with this black sticky material. This material, known as petroleum tar, washed up the southern Lebanese beaches following a petroleum oil spill in February 2021, resulting from the weathering of the spilled oil. It wasn't the first time that the Lebanese shoreline was impacted by an oil spill, and with the heavy oil tanker traffic in the Mediterranean and the planned oil and gas activities in the region, it doesn't look like it's going to be the last. For this reason, and to protect the marine life and biodiversity, it's essential to understand the fate of tar in the marine environment and prepare a sustainable plan for its cleanup.
Okay, thank you. It's a bit cut short, but that's okay. It's a very interesting topic. Okay, so I'd like to move on and introduce Fadis Abada, Snoring with Consequences.
Have you ever been to a construction site and ever came across a jackhammer? Despite the jackhammer's ability to pierce through concrete, it is no secret that a jackhammer can be very disruptive. Snorers can also be disruptive. And this is not, I'm not making this comparison to aim a dig at snorers, but rather to outline that despite the common ability of jackhammers and snorers to wake you up way before your alarm, jackhammers and snorers can also share another characteristic, and that is mechanical vibrations. Vibrations can exist on so many different scales, and even in more environments. And for an example, jackhammers, they can vibrate over a concrete surface, causing it to crack. So we ask ourselves a question: how does snoring fit into its environment, and how does it affect that environment? The carotid artery is the main blood vessel that carries blood to the brain, and it passes through the range of the mechanical vibrations caused by snoring. This is why my research focuses on simulating mechanical vibrations on the outer surface of a three-dimensional carotid artery model. And by doing so, we would be able to study the effect of mechanical vibrations on the outer surface of the artery. Much like any other artery, the carotid artery can be subjected to constrictions inside it. And those constrictions are caused by the buildup of material within the artery. This phenomenon is called the atherosclerosis. Now, simulations have shown that the carotid artery can be subjected to very high levels of stress from the simulation of the mechanical vibrations, and therefore causes a considerable amount of damage, which triggers the buildup of these materials. If we follow mechanical vibrations further, we can see that those vibrations can reach inside the carotid artery and interact with the blood flow. Interaction with the blood flow can cause the flow to be very much turbulent. And this turbulence can also interact with the environment around it, such that it causes a considerable amount of added pressure to the carotid artery. And if there exists a plaque, it would also interact with that plaque, causing it to rupture and move through the bloodstream. Thank you.
Okay, thank you, Ferdas. So, speaker number 5, Mohammed Badr Al-Zir, Risk Assessment and Economic Feasibility Analysis concerning debottling a 50-year-old transmission oil products pipeline.
Hello, everyone. Okay, next. Okay. So this research represents a real-life case study when the transportation pipeline was evaluated that is not qualified to accommodate the growth of the flow rate resulting from the increase of fuel demand in a country. The term debottlenecking used to describe the process of enhancing the output of an equipment by optimizing the procedure and updating the machinery. So the process is straightforward. We started with a thorough review of the stable operating condition, maintenance data, inspection records, and chemical property of the material. Following that, we conducted a feasibility study to review the applicability of any potential alternative, which included either constructing a new pipeline or building a booster pumping station. The financial impact, which is a game changer in oil and gas industry, was observed by doing some assumption to determine the total cost of ownership over the entire life of the project period. As well, health and safety is a very important factor in pipeline operation, which is observed by utilizing the 4 indexes of pipeline safety known as RIPS, which include corrosion, design flaws, incorrect operation, and third-party damage. As a result, we were able to increase the capacity by 100%. We achieved saving on the state treasury almost more than $100 million, and we reduced the risk by 30%. Thank you.
Okay, thank you very much. Very nice. So next we have George Deeb, predicting the outcomes of our body's battles.
Hello, ladies and gentlemen. So when militaries need to go into battles, first they used to study the 2D map of wherever they're going to. Strategies were done, and the mission was a go. Then 3D models started being used, whereby when the soldiers get into the battlefield, they know where they're going. They can see the alleyways. They know the buildings, how they will look, and their strategies could improve. Lastly, drills are conducted, as you can see at the end. So that's where battlefield environment is imitated and simulated. And that is when leadership can predict, for example, okay, this team is good, this team is not good, this strategy works, this strategy doesn't work. The pharmaceutical industry is the same. It's about an ongoing battle with various illnesses, and all of these battles are happening inside our body. So the pharmaceutical industry, there's a lot of costs, similar to warfare. There's the human cost, people are dying, there's a lot of, and also there's a lot of resources that are being put into the research in the pharmaceutical industry. So for every drug that reaches the end product to the shelves, it has to go through lab experiments, then some animal testing, then even several phases of human testing. And this is where it says that it takes around $1 billion to develop one drug. Estimates can go higher. And also, what is remarkable is that 90% of the drugs that work in the lab fail when they go into animal testing, and even a handful go into human testing to maybe get one drug. So what if we can better predict the drug performance inside the body to know how it will do in the battle that we designate for it, whether it's fighting cancer, Alzheimer's, any other disease? We can do the same. So what we were working in the lab, part of my thesis was, we were trying to construct a 3D environment. So we went from 2D cells on a petri dish to model a disease to a 3D electrospun scaffold. Okay, so it's just we imitated the architecture of the vessels, and then we grew cells on them, and then we took it further. We imitated the disease environment, whether it was flow, acidity levels, inflammation, injuries, all of this stuff. And so what we are aiming is that instead of 90% of drugs in the lab that succeed fail in animal testing, we are trying to improve that to maybe 90% of the drugs that we test in the lab will succeed in animal testing, and that way we can improve and better predict the drug's performance in the battle. Thank you.
Okay, thank you very much, George. So we're at the halfway point, actually, and we've just heard a number of talks, so I think it's been great so far. We're going to go to hear another 6. But before we move on, just because I want to reset our brains, because I don't want to bias your judging for the People's Choice Awards, I'm going to get you all to stand up and give yourselves a bit of a stretch and a bit of a punch in the air. If we had time, I'd let you have a 5-minute nap, considering what I always teach my students. You can have a nap and get re-energized. So a bit of a jump, a bit of a shake. Yeah, we reset ourselves. Okay. Well done. So when you're ready, just take a seat. I think I'll spend a bit more time up here. Okay. Okay. Okay, so we're moving on. Talk number 7. Zainab Walid Atoun, Stretchable Wearable RF Sensors.
I would like to introduce you to my grandfather, Rashid. Rashid was an old man who once got out of his bed in the middle of the night, fell to the ground, got injured, rushed to the hospital. However, he passed away. Later on, the reason of his fall was determined, and it was because his feet were too weak to hold him. Not only Rashid suffered from such death. According to CDC, 32,000 deaths are brought on by falls each year among the elderly. To decrease the fall in death rates and to offer a better life quality for the elderly, I designed a muscle strength detection sensor that can bend and conform when placed on the targeted muscle. This sensor is a filter. What is a filter? A filter is an electrical component that can prevent or allows electromagnetic waves of passing at a certain frequency, let's call it F1. But this sensor is not just any filter. It is a filter it is a flexible and stretchable filter that is separated into 2 parts with a specifically microfabricated electromagnetic gap between them that determines the frequency. So the contraction of the muscle will cause the filter to stretch, leading to an enlargement of the electromagnetic gap, which will cause the frequency to change from F1 to another frequency, to a higher frequency F2. However, the relaxation of the muscle will do quite the opposite. It will cause the filter to compress, leading to a reduction in the electromagnetic gap, which will cause the frequency to shift back to F1. So this frequency variation is monitored in order to determine the muscle strength intensity. How to monitor frequency variation? Well, I've also designed a tiny flexible wearable circuit to be connected to the sensor that can transform the frequency variation to voltage variation to facilitate its integration with a wireless module, so a notification can be sent to the caretaker about the user's muscle health. And then the necessary measures can be taken if the user is in danger. Although such sensor can be used by athletes, astronauts, people with cognitive disorders, I've mainly designed it for the elderly, for people like Rashid. So if such sensor existed previously, then maybe, just maybe, Rashid could have been watching me today among the audience instead of the skies. Thank you.
Okay, thank you. And moving on to our next speaker, Naeem Azraib, the production of time, an architectural time machine.
Think with me for a second. Imagine if time were an escalator. We have 5 possible attitudes towards this escalator. We could be completely indifferent, not even look at it, not even think it exists. We could be partially passive, so we could see that it's there, we could kind of look at it, we could maybe see that it's there. Third of all, we could be responsive, so we could walk on this escalator and let it take us somewhere, let it take us to its destination, follow it. Fourth of all, we could be interactive, so we could look in the other direction of the escalator, challenge what it is, not only take it from one point to another. And fifth of all, and most importantly, we could be productive. We could not only see this escalator as for what it is, we could walk upwards with it, therefore accelerating, or walk backwards, therefore decelerating. That attitude towards that escalator is what this thesis, or my thesis, looks about time. So time is not something that we want to be just passive about, or even interactive, or even responsive, or to register it, to think about it. We want to be productive of time. Architecture has always been the design of space, or the production of space. Therefore, this thesis says that it's the production of space and the production of time hand in hand. In space, what we have is a point in 0 dimension. Extended becomes a line. Extended becomes a plane. And extended, again, becomes a 3-dimensional cube or object, which becomes this space which we're living in, which becomes a building, which becomes anything which architects design, or which builders and engineers design together. What I'm saying is that in time, we have the same thing, which is not deliberately designed, which is not thought about. In time, we have a single point, so it's an instance. If we extend this instance, we have a duration between 2 instances, or between 2 times. Extended again becomes the 3rd dimension, which is the multiple perceptions of this same thing. So what if I thought that it's very quick, you thought it's very slow? What if I thought that it's beautiful, you thought that it's not? Multiple extensions from the 3rd dimension to the 4th, to the 5th, to the 6th, to the 7th, all the way to the 8th. So time is no longer thought in architecture as just a 4-dimensional object, or even a 3-dimensional thing. It becomes a physical, tangible, visual aspect through an algorithm, which is 8-dimensional, which incorporates all the different dimensions of space. And architects, builders, designers don't only think about space and designing physical coordinates. So we live right now in the here. So I'm right now here, but I'm also in the now. People, architects no longer design just the space of it, but the time of it deliberately. Therefore, to reiterate and to conclude, the whole thesis which I'm working on looks at architecture again, no longer as the production of space or the design of space as a whole, but the production of space and time together, a space-time continuum, as discussed in physics, as discussed in philosophy. Space and time together in all of their characteristics, in all of their explorations, and in all of their multiple faceted effects on humans and the construction process. Thank you.
Great, thank you. And we move on. So talk number 9, Zena Habli, The Force Within, How Cancer Cell Mechanics Can Make Cancer Screening Fast and Cheaper. Thanks, Zena.
To
Talking about cancer is always challenging in Lebanon, especially when we know that most of us are at high risk of getting cancer during our lifetime. Considering the bad healthcare system we have, the high levels of pollution we live in, and the unhealthy lifestyle. So what should we do? Scientifically proven, early cancer detection saves lives. It increases the chances of someone from dying from cancer from 37% up to 85%. So what should we do? Should we screen everyone annually using full body scans like MRI? Well, this is not practical because we don't have the money nor the resources to do that. Fortunately, the blood of a cancer patient have a unique type of cells called circulating tumor cells. These cells detach from the primary tumor, circulate in the blood, and spread the disease into the body in a process called metastasis. These cells carry insightful information about the cancer status, but the number is very low and they are very hard to be detected. These cells are very dynamic when it comes to mechanics. They're very elastic and soft in order to detach from the tumor and squeeze themselves throughout the tissue. Therefore, my research is bifurcated into two parts. The first one is to assess the mechanical properties of cancer cells using a unique model of cells that have a gradient of aggressiveness: non-aggressive, aggressive, and highly aggressive. I study these cells at a single cell level, determining how elastic, viscous, stiff these cells are, and then I try to predict the likelihood of these cells to produce CTCs that are metastatic. The second part of my research is to develop a low-cost bimodal chip that is capable of detecting CTCs in a blood sample using their unique mechanical properties. The chip can detect the cells and count them using the 12,000 detection sites, where every site is a small well that can bear a single cell. When a cell lands on top of the well, a signal is to be recorded, and if the signal matches that of a cancer cell, then the patient is suspected to have cancer and must be sent to the clinic for further assessment. The chip is cheap to fabricate, and it delivers results within a few minutes. We hope with our approach to facilitate early cancer screening and make it accessible and affordable for everyone out there. That's it. Thank you.
Okay, thank you, Zana. So, talk number 10, Abdulrahman Al-Talis, evaluating the effects of mucilage from Opitia, I'm sorry if I can't pronounce that, ficus indica on the structural performance of concrete. Thank you.
Good morning, everyone. My name is Abdulrahman Talis. I'm here to talk to you about our ongoing research in the SAUB Civil Engineering Lab, where we're conducting research on the mucilage extracted from the Opuntia ficus indica cactus and its effects on the structural performance of concrete. Concrete is a critical construction material responsible for around 8% of our total CO2 emissions, while being the second most used material after water. Previous research has incorporated Opuntia ficus indica mucilage, also known as OFM, in concrete, and have reported increases in the durability and the strength. However, no large-scale testing or real-life applications has been done at UB, nor reported in the literature. This is where we come in. To conduct this study, we used three mixes: a conventional mix of concrete with no additives whatsoever, a second mix with a 15% water replacement with OFM, a third mix also with 15% OFM, as well as another percentage of a super plasticizer to see how it often behaves when mixed with a common additive in the construction industry. We tested reinforced concrete beams and cylinders for 9 performance parameters across 3 tests. We exhibited improvements in every single one of them, with the most significant being related to the shear properties. In short, often modified concrete was able to withstand higher loads and became significantly more ductile. We also reported good behavior with the super plasticizer, as well as better bond with the embedded steel reinforcements. This was accounted to the adequate bonding between the mucilage and the cement. In addition, we were able to express some economic and environmental benefits based on the structural performance improvements. We were able to conclude that a 10% reduction in the cement content is viable while keeping the desirable performance standards. Therefore, we can save up around 15% of the CO2 emissions and the cost of the production of conventional concrete. Our research has significant implications because not only does it improve the technical aspect, but also provides savings on the carbon footprint and the costs of the production of concrete. We're trying to introduce a new type of green concrete with a sustainable bioadditive with added value for the construction industry. In the end, in order to promote this product, we will be carrying further testing on a larger scale of mixed variables and applications. Thank you for listening to me. I'll be more than happy to answer your questions.
Thank you. So Mario El-Hourani will be presenting to us next a mathematical model that predicts harshness of electronic cigarette aerosols.
Hi, everyone. So imagine a kid picking up a cigarette for the first time. They take a puff and immediately experience a harsh sensation at the back of the throat that might deter them from ever smoking again. This harsh sensation, commonly known as throat hit, results from the stimulation of sensory nerves in the throat region due to nicotine vapor absorption, and depends among several variables on the type of nicotine used in the electronic cigarette. Now, if that same kid tried an electronic cigarette that delivers nicotine without the harshness of cigarette smoke, they might actually enjoy it more and be more likely to keep using it, especially if flavors are involved. But why does this matter? Knowing how harsh or pleasant a certain aerosol will be in someone's throat can help us understand how appealing it will be. And this is important information when it comes to regulating tobacco products. So it would be very useful to regulators to have a tool that can predict the harshness of electronic cigarettes, and in this work, we aimed at providing them with that tool. To do that, we used our engineering knowledge in aerosol science and heat and mass transfer to simulate the flow of the aerosol generated by electronic cigarette in a realistic geometry of the upper airways. The model is provided with the electronic cigarette geometry, operating power, liquid composition as inputs, and after solving a series of equations, it outputs the amount of nicotine vapor absorbed in the throat region. Now, we found that the model reliably predicted the throat hit sensation reported by actual electronic cigarette users that smoked their devices under various operating conditions. Now, the main innovation of this model is that it can predict harshness, that is, a subjective sensation, by just knowing the physical properties of the electronic cigarette. Moreover, regulators can use this model to explore the effect of various design variables of electronic cigarettes on harshness, and they can assess the appeal of a given tobacco product even before its release into the market. Thank you.
Okay, we're at the finale, and lucky last is Helen Najjar. What can your wrist tell you about your health?
Nowadays, Apple Watches and fitness trackers are everywhere. They can give you information about how many steps you've taken in a day, and even your heart rate. But especially given how expensive they are, shouldn't they be able to do more? The wrist is actually a really tricky place. We move around a lot during the day, and we sweat, and everybody has a different wrist size. So given that, I want to create a device that accommodates all wrist sizes, that can give us specific information about our heart health, about our fitness goals, and what our body's made of. And that's where BioZ comes in. BioZ is a very small, safe electrical signal that's sent throughout the body. What's so amazing about this is that it can give you detailed information about your muscles, about your bone, and about the rest of the tissues in your body. So since BioZ can do so much, it could even tell you how hydrated you are and how your blood is flowing, which could give detailed information about heart disease. Since it's so amazing, why not introduce it into a wrist device? One thing I'm going to look at is tightness of the wearable on the wrist. If the wearable is too tight or too loose, this could negatively impact the quality of the signal. Further, the way that I'm going to improve this is by using something called a strain gauge. A strain gauge is a small device that could give us information about pressure on the wrist. So now we have BioZ, this signal that gives us information, detailed information about what your body's made of. And we also have the strain gauge, which can tell us about how tight or how loose the device is on your wrist. But we're still missing one more thing. We need an electrode. I'm going to find the best material that can send the signal, interact your body with the device, that can send the signal throughout your device, throughout your body. Why is all of this important? Instead of waiting for a health problem or delaying your fitness goals and waiting for a health problem to arise, we can tackle all of this beforehand. It's like having a personal health coach right with you every step of the way. And it all starts with BioZ and your own wrist. Thank you.
Okay. So we've done it. We've gone through 12 talks, and they're all very, very good talks. And here's our list of presenters again, so I'll get you to put a round of applause for all of you guys. So well done. It's an extremely challenging, extremely tense environment, so I think they did a wonderful job. Now comes the time for you guys to vote for your best presentation. So what you're going to do now using your phones is go to slido.com, and you're going to just enter this code that's going to give you the list of people that you can choose from to present in a second. So it's 9554215. And I've got it on this slide here again. So I'm going to only open this up for a couple of minutes. So slido.com. And the code is up there on this slide as well again. So is anyone having trouble accessing it? It's all good. I've already seen some votes coming in. Okay, so I'm going to leave it open for another minute. So please get your votes in as soon as possible. Okay, I'm going to stop the voting in 5, 4, 3, 2, 1. Okay, so thank you very much for participating in that. So now what's going to happen tomorrow at the MSFEA Awards, you'll have the announcement of the People's Choice Award winner and the Best Presentation winner. And so I'm going to end this session, and again, just give a round of applause for the participants and for yourself. So thank you for coming to the session, and we'll see you at the rest of the conference.